So we can talk about how an action potential moves down the length of an axon. So action potentials begin primarily in a part of the axon called the axon hillock. So they originate and the axon hillock is that part of the axon that connects the axon to the cell body. Now we have two types of conduction. So we have one, which would be continuous conduction, which is actually quite rare in our bodies. This continuous conduction means that there's no myelination. So this happens in unmyelinated axons. And it is slower than the other type of saltatory or other type of conduction, which is called saltatory conduction. Saltatory actually means that's a saltatory conduction means jumping. So this would be myelinated axons. And most of your axons in your body are myelinated. It's kind of interesting. When we're born, we still haven't myelinated all of our axons, and so our early movements are kind of jerky, and they're not really smooth, and they're kind of slow. And so as we develop these connections between our muscles and our nervous system, then they become myelinated, and then our movements become more graceful. So let's look at a diagram that shows this. So where is the myelin? The myelin is actually in the Schwann cells. So the Schwann cells are a type of glial cells. So when we look at myelin, we have Schwann cells, and these make up the myelin sheath. This is insulation. This is speeding up of conduction. So this speeds up the conduction, the velocity, the conduction of the action potential. Okay, so these Schwann cells are shown right here. Oops, didn't want to use that. Right here. And you'll notice that there are spaces between the Schwann cells. Now the Schwann cells are actually named after a person, as are the spaces. So the spaces are called nodes of Ranvier. And so only in those unmyelinated spaces do the sodium ion channels open and the sodium ion floods in. So this is saltatory conduction, kind of like jumping. And that is going to lead the action potential to reach the end of the axonal terminals. And this is where the neurotransmitters are going to be released into the synapse. So let's look at this continuous conduction. We have no myelin. And so this conduction of the action potential is going to be continuous, and it is slower. Almost all of our axons have some myelin in them, so this is rare. There are a few axons in the involuntary part of our autonomic nervous system, which are unmyelinated, but all of our motor neurons that synapse with our skeletal muscle, they are all myelinated. So we can talk about what happens if this myelin goes away. So we can talk about what is called demyelination or demyelinating diseases. And one example of this is multiple sclerosis. And this is actually an autoimmune system or autoimmune disease where your immune system attacks the Schwann cells. There is no cure for this, but there are mechanisms to kind of treatments that kind of slow down the demyelination. But eventually, what tends to happen is that people might lose the ability to walk, might have to be in a wheelchair, and you can eventually die from multiple sclerosis, or MS as it's referred to. Now, there's another demyelinating disease that you might have heard of, and it is called Guillain or Guillain, actually Guillain. I always want to say it different. I think it's French. It's named after a person. And it is called Guillain-Barré syndrome. And this is where you have temporary demyelination, usually after you have been infected with a virus. So this could lead you to be paralyzed almost overnight. It's very crazy. So you get a virus and then you feel like you're getting over it. And then all of a sudden your immune system kind of goes crazy and demyelinates your axons. And so you become paralyzed. And then you go into the hospital and you have to spend months in rehabilitation while your system becomes remyelinated. So this can be the myelin in this particular instance is repaired over months, if not years. So we'll put slowly. And humans are not the only people that get Guillain-Barré. I know dogs can get it too. But generally, if it's in an animal, the cost of the rehabilitation period would be just too much, right? So most people do not have their dogs. They generally would euthanize the dog if it got Guillain-Barré. But this is another example of a demyelinating disease. And these diseases show us how important the presence of the myelin on these axons is.